Alright, what is up guys? Simon from Brainy-Bits.com, and if you remember our last video, we ordered and created some PC board using the online service ezda.com, and they arrived. So let me show them to you. So this is the way it's packaged, came like this, and here is the board itself. So let me zoom in on this so you can see it a little bit better. There you go. So the boards are very well done. They look very nice. The silk printing is very well done. All the holes are true plated, so meaning there's metal all the way through the other side. So when you solder it, it's very easy to do. And here's the final product, basically. And there you go. So that's the board with everything soldered on, including the MX switches. And on the other side. So the other side, you can see the DigiSpark right there, and the CD 4021 shift register. And I've used little headers, so that way I can remove the part in case, you know, this guy burns out or something, so I can just replace it easily without having to desolder anything. So it just goes in like that. So how I went about to solder this, let me just remove all the keys here. There we go. So the keys are gone. So I went about to solder this. I'm going to show you a speed up video right there. What I'm using for equipment, it's from my experience. Basically, I use a Weller WES51 soldering station. It's got no bells and whistles. You just adjust the temperature and use the soldering iron that comes with it, the PES51, I think, the soldering pencil they call it. And in my mind, you know, there's better models out there with digital readouts and stuff like that that you could adjust the temperature. But in my experience, basically, I set the temperature once and I basically never touch it again. So for me, it wasn't worth actually getting a higher end model. Now, the next part, the next tool I find makes the job really easy is some way to hold the boards. I mean, we've all used these magnifying glass third hands. Everybody's got one, it seems. They're easy to find, they're cheap. They do the job for smaller boards, but they're kind of finicky. They fall over, and you could always put a heavier base on it, I guess. But recently I got this thing, I think it's the ESF20 from Weller, and I actually soldered these boards using this, and it was so much easier thanks to the fact that it holds the board and you can flip it around, but it has a little arm that actually pushes on the part while you're soldering it. And when you flip it around, it stays in place. And by the way, I'm not sponsored by Weller or anything like that. If I ever get sponsored to do a video, I'll let you guys know in advance. But these are the tools I use. I'm just talking about my personal experience. So let's put this guy back together. All right, so I've put it back together with the switches, as you can see. So switch M is for our main camera, because I'm going to use this button box to control my video switcher when I make videos. The C is for the close-up camera, which is the one you see now. The S is for sharing my screen. And then I programmed the F1 to do a simple cut, and the F2 to do a fade in and out of both cameras. F3 is not programmed right now. So what we're going to do now, we're going to revisit the code to see how I program my button box. And then we'll come back and I'll show you how it works. So let's go check that out. All right, so here we are in the code that we used last time in the last tutorial. If you missed it, you can go check it out here where I explain more of all this coding here. So if you haven't seen that video, go check it out and you'll get more explanation on all this stuff here. So for this one, I'm just going to skip down to the part where we program the buttons, and it starts here. So basically, when we read the value of the shift register, if the value is this, which is the first button, the top left, then I send to the keyboard the key 7, the number 7, which on my Atem Blackmagic design switcher will switch to the main camera. Then I do a very small delay. And as you see here, I commented out this line. That's the way I found the register value for each one of the buttons. So basically when I pressed a button, it would send out via keyboard, USB keyboard, the register value, and the register value was this. So that's how I know what these values are for each buttons. So here I'm sending 7, that's my main camera. Here on the second button I'm sending 5, that's my close-up camera. And this one is the screen, so number 1. And then to do a cut on my software, it's the space bar. So this is the code for that. And to do fade, it's enter key. And this is the last button that I didn't program, so it's enter also. So by just modifying the printout here, you can actually create anything you want. You could do a macro. Let's say it sends a character, and then you do a delay very small, let's say 10 millisecond, and then you send another key and another key and another key, so that could be a macro. So that's all there is to it, and you can play around with this, and depending on the keyboard shortcuts for your software, you just have to modify these values here. So that's it. So let's program the DigiSpark, and let's go back and test it out. All right, so now we uploaded the code to the button box. And what I'm going to do now, I'm going to plug it in and I'm going to show you how it works. So let me switch the camera manually with my keyboard right now. So as you can see, we have the button box, and I'm going to plug it in right now, right here, using USB. So let me do that. Which way? This way. There we go. And we're just hearing it. And there we go. Now it's ready. So basically, you're going to see in the window right over here every time I push one of these buttons. So right now, we're on the close-up camera, which is the C that you see there, right there. So if I want to switch to the main camera, I'm going to press once and then switch using this key. And there we go. Now we're back to the main camera. I'm going to go back to close-up, pressing C and F1, and we're back. Now let's say I want to do what's called a fade in, fade out. So I'm going to choose which camera I want to fade in, the M in this instance, and instead I'm going to press F2. And there we go. Now we're fading in from one to another instead of doing cuts. And the last one is S for screen. So I'm going to prepare it and then F1 to switch to the screen like this, from one to another. If I want to move back to the main camera and fade in, F2, and now we're fading in. And fading back, close up. And it works really well. It works really fast, as you can see. So there you go, guys. The button box, 6 programmable buttons. You can do whatever you want. You can send text, a string of text. We can control anything that's controlled with a keyboard with hotkeys. You could make macros if you're playing games. The press of one could do a multiple keyboard presses. So there you go. So it looks pretty good like this. When I have more time, I'm going to design an enclosure for it using the CNC and vacuum form something so we have a proper box to put in. So I hope you enjoyed this little project, and we'll be back very soon to design an enclosure for it, and I'll let you guys know how that's going. So let's go back to the main camera and wrap it up. All right, so that will do it for today's video. Like I was saying, I hope you enjoyed this one. I find it, I'm going to use it every time I actually do a video to switch my cameras. Instead of reaching out to the keyboard, I might just have it here very close to me and I can rest my hand on it and actually do the switching this way. Like I said, I'm going to move on now to do an enclosure for this. So that will mean to design something in 3D using Fusion 360. And after that, milling it on the CNC and doing a vacuum form and using the laser to cut out the holes needed for the switches. So that'll be coming soon. The next video is probably going to go back to a tutorial type of thing. I've had a lot of requests for people to control multiple stepper motors. So I'm going to try to come up with a cool project and show you guys how I do that. So like I said, using a real PC board, professionally made, makes everything a lot better, but the cost of the shipping, sometimes will hurt. But if you want your project to be permanent, sometimes it's worth investing and doing something like this. You could always use this, of course. This works also, but if you can go with this, this is a lot better. So that's it for today, guys. I hope you enjoyed this video. Please remember that if you want more information on this, And all our other tutorials or videos, you can go to brainy-bits.com/tutorials, where you'll find articles if you need to, where you can download the code, the libraries used, and more information. And also, if you need parts and stuff like that, you can buy electronic parts in our store, and it helps us a lot. So until next time, guys, my name is Ivan, and I hope to catch you guys real soon. Take care.